Dresden chip boom puts water infrastructure in focus. Behind Dresden's 5 billion plus chip expansion sits a critical resource challenge, securing the ultrapure and recycled water modern fabs depend on. Gradiant has completed its water infrastructure scope for a major semiconductor manufacturing expansion in Dresden, Germany, finishing the work 3 months ahead of schedule. The broader project represents an investment of approximately $5.8 billion and is expected to double manufacturing capacity at the customer's existing Dresden site. Around 1,000 highly skilled jobs are also expected to be created as additional production comes online. Located within Silicon Saxony, one of Europe's largest semiconductor manufacturing clusters, the expansion forms part of wider efforts to increase regional chip production and reduce vulnerabilities in critical technology supply chains. Approximately $112 billion in public funding is supporting the development through initiatives including the European Chips Act and the Important Project of Common European Interest, IPCEI. Ultrapure water and recycling supports semiconductor production. Gradiant supplied ultrapure water production and water recovery systems for the expanded facility, addressing two important requirements for semiconductor manufacturing: maintaining strict water quality and managing overall water demand. Semiconductor fabrication uses significant volumes of ultrapure water during wafer cleaning and rinsing. Contaminants at very low concentrations can interfere with manufacturing processes, making water treatment and monitoring an important part of fab reliability and production yield. The Dresden operation is designed around 300mm wafer production and will manufacture power semiconductors as well as analog and mixed signal technologies. These components are used in applications including electric vehicles, industrial equipment, renewable energy systems, electrical grids, and data center infrastructure. Alongside ultrapure water production, Gradiant installed rinse water recovery systems that capture water from selected manufacturing processes for reuse elsewhere in the facility. Recycling water within the fab can reduce demand for incoming supplies, while giving operators greater control over water availability. The facility is also expected to use industrial water rather than drinking water for production. Combined with internal reuse systems, the site is targeting a production water recycling rate of up to 45% by 2033. As semiconductor fabs increase in scale and manufacturing complexity, water availability is becoming a more significant factor in site operations and future capacity planning. Recycling does not remove the sector's need for substantial water supplies, but it can reduce consumption and improve resilience where local resources are constrained. Dresden expansion puts water infrastructure into the chip supply chain. Completion of Gradient's scope 3 months ahead of schedule comes as European semiconductor projects face pressure to add capacity while maintaining demanding standards for commissioning, reliability, safety, and process quality. According to Gradiant, delivery involved coordination between its engineering teams, the semiconductor manufacturer, and other project partners. The company's management has positioned the Dresden installation as an example of how water treatment requirements are becoming more closely connected with semiconductor production planning. That connection is likely to become more important as additional fabrication plants and capacity expansions move forward. New semiconductor facilities require not only manufacturing equipment and energy infrastructure, but also dependable systems for ultrapure water generation, reuse, and wastewater management. For operators, that makes water increasingly relevant to decisions around fab location, production resilience, and long-term expansion. In Dresden, the new infrastructure provides another example of how resource management is becoming part of the wider semiconductor capacity discussion in Europe.